Hello students and welcome back to my channel. In this video we will be discussing questions based on optics which were asked on 29th of January 2024 JEE Mains. So in continuation with the other videos, you can kindly check the other video students. So we are about to discuss question number 44. Here comes question number 44. A convex mirror of radius of curvature 30 cm forms an image that is half the size of the object. So the object distance is. It's very simple students. You have a convex mirror. This is the object. And the image is exactly half. This object is the image. So in that case, if you take the image distance as x, this is the pole, then object distance will be 2x. Okay students, because the size of object is twice the size of image. So proportionately the image distance will be half the object distance. So always take the smaller value as x so that the bigger value will be 2x. Also focus will be somewhere here and focal length will be positive. So focal length is half the radius of curvature students. So half of 30 is 15 cm. So we will be using the mirror formula which states 1 by b plus 1 by u is equal to 1 by f. So b is plus x, u is minus 2x is equal to 1 by 15. So we have 1 by x minus 1 by 2x is, I'm sorry students, is 1 by 15. Okay, right. So x is equal to 15 by 2 cm. But since we are asked to find the object distance will be double of this. So we have 15 cm. Since the object is placed to the left of the pole, so we will go with the minus 15 cm option. Okay, so here. Right. Moving on to the next question. A biconvex lens of refracting index 1.5 has a focal length of 20 cm in air. Its focal length when immersed in a liquid of refracting index is much. As we know students that the focal length of a lens in ordinary air, that is when surrounding medium is air, is simply mu minus 1 into 1 by r1 minus 1 by r2, which I can write it as k. So k depends only on the radius of curvature of the two faces. That's all. It will not change when you immerse this in some other liquid. Now, when you have some other liquid as the background medium, then you have to divide mu. Here, mu is the refractiveness of the lens material, and this you have to divide with the background medium minus 1 into k. Okay. So, for example, in this situation, what they have given, let us see. Focal length in air is 20 cm. So 20 cm is equal to mu minus 1. 1.5 minus 1 is half. So I can write k as 1 by 10 cm. So the new focal length in the liquid will be mu divided by refractiveness of the background medium minus 1 into k. So this is 15 by 16. So this is 1 by 16 students, and k is 1 by 10 cm. So clearly you can see the focal length in the liquid is minus 160 cm. So we will go with the second option. As a matter of fact students, just a small reminder here. When the surrounding medium, refracting index of the surrounding medium exceeds that of the material of the lens changes its nature. In other words, if it is a convex lens, it will start behaving as a concave and vice versa. Right? Okay. Moving on to the next question. If the distance between object and its 2 times magnified virtual image produced by a curved mirror is this, it is a focal length of the mirror. Now students, it is given that 2 times magnified. That means size of image is bigger than that of object, and also at the same time it is virtual. So the only mirror which produces magnified virtual image is concave mirror, because convex mirror also always produces diminished virtual image. So this is the scenario. So the mirror is a concave mirror. So we have to find the focal length of the mirror. So let us say this is the object, this is the image. If you take object distance as x, image distance will be 2x, because it's clearly given that the size of image is double that of the object. And also it is given that the distance between the object and its image is 15 cm. So if you divide this in the ratio 1:2, this will be 5 cm, this will be 10 cm. So we got the object distance and image distance. So we will be using the mirror formula. 1 by v plus 1 by u is equal to 1 by f. So focal length will be this, 1 by v. You can see v is plus 10 cm. So plus 10 cm. Whereas the object distance is minus 5. So minus 5. Okay, students. So 1 by 10 minus 1 by 5 will be, of course, 1 by 10. So focal length is minus 10 cm. Of course, focus lies to the left of the mirror. So certainly the focal length has to be negative. Okay, students. Then moving on to the next question. In a YDSC experiment, light from two identical sources are superimposed on screen. Path difference between the two lights reaching at a point on the screen is this, the ratio of intensity of the fringe at this point. So very simple question, students. We know intensity in terms of maximum intensity is this into cos square of phi by 2, where phi is the phase difference between the interfering waves. As you can see, they have given the path difference between the interfering waves as 7 lambda by 4. So we can equivalently convert this into path phase difference, because if a path difference of lambda is equivalent to a phase difference of 2 pi radian. So this will be 7 into pi by 4. Pi by 2, sorry, students. Okay. So when you substitute here, so 5 by 2 will be 7 pi by 4. Pi by 4 is 45 degree. So odd multiple of 45 degree. Okay. Now students, you see, when if it's a integral multiple of 45 degree angle, then its cosine will be either plus 1 by root 2 or minus 1 by root 2. If the angle falls in the first and fourth quadrant, cosine will be positive, whereas if it is in the second and third quadrant, cosine will be negative. So what will be the case, whether it is positive or negative? Anyway, you have to square it. So finally you get half. So half is the factor by which it changes, or we can write that intensity ratio related to the maximum intensity is half. Okay, students. So we will go with the first option. Then coming to section B, in a YDSC shown in figure, when light of wavelength 400 nanometers is used, dark fringe is obtained at P. D equal to 0.2 meter, minimum distance between states. This is the figure, students. Okay, figure is not to the scale, so it's very, not very appropriate, because D is 0.2 meter. 0.2 meter means 20 centimeter, and this will be a few millimeter. So certainly it's not according to the scale. Okay, right. So here we will see what to do. Suppose this is the slit S1 and S2. Light coming from the original source will straight away move and reach here, whereas light coming from this way, it has to cross all the way and come like this. So you can take its image here. So image of source SO is SO dash. So in other words, we will see like this. One light ray is coming this way and the other light ray is coming this way. So you just have to find the path difference, because these two are same. This and this is same. So the path difference will be SO dash P minus SOP. This is the path difference. If C is the midpoint of SO and SO dash, and if You join it with P. This angle is theta, and the distance between the slits is A, let us say A. Then this path difference will be A sin theta, which will be approximately equal to A tan theta, because theta is very small. Okay, students. So this will be, this distance is given as small d. We have to find the minimum value of small d. So I take this as d. So this is d and this d. Okay, a will be 2d. So this is 2d into tan theta. Tan theta is small d upon twice capital D. Remember, students, this is twice capital D. From here to here it is d, and from here to here it is d. So 2d. So this path difference, if you want to have minimum value of d here, then we should ensure minimum value of path difference which corresponds to a dark fringe. Okay, and that should be minimum path difference corresponding to dark fringe is lambda by 2. So therefore I can write that minimum value of small d whole square upon capital D is equal to lambda by 2. So minimum value of d upon capital D. Capital D is 2 into 10 power minus 1 meter. Lambda is 200. Now lambda by 2 is 200 nanometers. So nano stands for 10 power minus 6. Okay, students. So all the units are in SI unit. So d min is equal to 4 into 10 to the power minus 1. So this will be minus 6. So therefore d min is equal to 2 into 10 to the power minus 3 meter. Okay, students. So 2 mm is the answer. Moving on to the next question. In a single slit diffraction pattern, the light of wavelength 6000 degree angstrom is used. The distance between the first and third minima in the diffraction pattern is found to be 3 mm, where the screen is placed in the width of the slit is. So the diagram will be something like this. So this is the central line, this is the screen. The intensity distribution on the screen will be something like this. Okay, students. So this is the position corresponding to the first minimum, whereas this is the position corresponding to the third minimum, of students. So first and third. So I hope we should go with this. It's not writing, I can't understand what happened. So this will correspond to this is the first dark fringe, second dark fringe, third dark fringe. So this is the position corresponding to third one. So this distance is given as 3 mm, and this distance is given as 50 cm. 50 cm can be written as half meter. Okay, students. C is the midpoint. AB is the slit. So we have the condition here, students. If A is the slit width, then I can write A sin theta 1 is equal to 1 lambda, and A sin theta 3 is 3 lambda. So if I take the difference, I have a sine theta 3 minus sine theta 1 is equal to 2 lambda. For small angles, we can replace sine by tan. So I can write this as, because we have been given this value. So we have to replace this in terms of tan. So I can write this as tan theta 3 minus tan theta 1 for small angles. Okay, so tan theta 3 means this upon this. Tan theta 1 is this upon this. So when you take the difference, you have 3 millimeter. Milli here, milli stands for 10 power minus 10. So 3 millimeter upon capital D. Capital D is half, is equal to twice into lambda. Lambda is given as 6000 angstrom. So 6 into 10 to the power minus 7 meters. So all the expressions I have substituted in SI units. So let us see what we get. So this 2 and 2 gets cancelled and 3 2s are. So A is equal to 2 into 10 to the power minus 4 meter, which is 0.2 mm. So it should be numeric value. So this is 2. Width of the slit they are asking 2 into 10 to the power minus 4. So this is 2. Alright students, that's all students in this video. Thank you so much for watching my channel. Please subscribe to my channel and hit the like button. Thank you.